I'm Steve Temme, and today I'm going to demonstrate the new features in SoundCheck 23. This release is a big one for us, as this year marks our 30th anniversary. When I created the first version of SoundCheck from the corner of my bedroom back in 1995, I had no idea that it would evolve into such a sophisticated audio test toolkit, or that some of those early algorithms I developed would go on to become industry-standard test methods. This new release offers new functionality and performance improvements for both R&D and production testing. These include real-time tonal masking curves for detailed perceptual audio analysis, a new multi-channel oscilloscope, a new time frequency cursor for recorded sweep waveforms, and support for AudioConnect 8x8, our newest multi-channel interface. We've also improved performance, particularly for graphical display, and updated the sequence editor for faster test development. Let's take a look. We'll start with masking curves. This is an industry first, real-time tonal masking and threshold of hearing curves in a spectrum analyzer. This shows you where a dominant tone is audibly masking other frequencies and noise and gives you a clear visual correlation of measurements to audibility. You can use this for identifying the cause of audible distortion. Let's say we have a speaker that is failing a production line perceptual rub and buzz test. Your results might look like this, and you can see that you have audible rub and buzz in this frequency range here. Now, if you want to drill more deeply into that and understand what's causing the distortion, we can use masking curves. We can play a 1 kHz sine wave through the signal generator and look at the FFT spectrum here. Now let's add a masking curve. You can specify in here exactly what type of curve you want. It automatically tracks the dominant tone in the acoustic signal. This makes any harmonics above the masking and threshold of hearing curves clearly visible. And if you look at the shape of this curve, you can see that it combines the masking from the fundamental here and also the threshold of hearing curve. You can see it increasing up here in the low and the high frequencies. And you can see which of the harmonics are above this purple masking curve here. You can see that the even harmonics are well below the masking curve, so they're inaudible, but the odd harmonics, 5, 7, and 9, are well above it, and that's what you're hearing. I can also experiment with this at different frequencies. For example, I can go lower in frequency and see if the distortion is audible there, or higher, and I can try different levels and observe the impact. This feature has R&D applications too. For example, when you're selecting product components, it helps balance component quality or size with cost so you can avoid audible distortion while not over-designing to reduce distortion that you can't hear. For example, making the loudspeaker driver's magnetics more powerful than they need to be for their application. The new stimulus frequency cursor lets you quickly identify the frequency at which an event occurs. Here I have a time domain response from the enhanced loose particles algorithm. You can see that there are transient events here, so if I position my cursor over them, I can see a clear readout of the stimulus frequency where these transients occur. This feature is available in all step sign measurement waveform graphs. A few versions back, we introduced the frequency counter to precisely measure the frequency of electronics, rotating devices, or electroacoustic devices. Now we've added custom unit conversion so that frequency can be mapped to any units you want. For example, to plot fan noise levels against speed in RPM, or to map road noise levels to the speed of a car. Here I have a fan with a piece of reflective tape on it and an infrared laser. When the laser hits the reflective tape, you can see the laser lights up and returns a voltage pulse to SoundCheck. Right now, the counter measures how many times per second this happens to output this value in hertz. RPM is more commonly used to measure rotating devices like tires or fans, so let's apply a custom conversion. I just select an operation, a conversion factor, and a new unit. I'll multiply it by 60, and now we have our fan speed displayed in RPM. We can also look at the change in RPM over time on the strip chart, and you can overlay these values with any other measurement, for example, to plot tire noise level against speed. If you've been following SoundCheck for a while, you've probably noticed that all our single-channel instruments have transitioned to the new multi-channel format. In this release, the oscilloscope is now integrated into the standard multi-instrument. This means that, like the FFT analyzer and real-time analyzer, it features full multi-channel capability, and you can display multiple live waveforms on the same graph. You can even display synchronized RTA, FFT, and oscilloscope outputs at the same time, as there's a shared trigger. This makes it easy to view measured parameters in both the time and frequency domains simultaneously, for example, to look at interchannel time delays and crosstalk. SoundCheck's displays are improved with increased speed and stability for large data sets, for example, when displaying multiple graphs or multiple curves on a graph. This makes it much quicker to work with your data. We've also added additional functionality, including zooming, using the mouse scroll wheel, and panning using either mouse or keyboard controls. You can now zoom in and out on a graph using the wheel on your mouse. If you just use the scroll wheel, it'll zoom in both directions. If you hold down the Shift key while you scroll, it'll zoom on the X-axis only, and if you hold down the Control key, it will zoom on the Y-axis only. We've improved the sequence editor to make it easier and faster to develop sequences. It's now faster to open, edit, and close a sequence step, especially in larger or more complex sequences. We've also added some new sequence editing functionality. You can now copy and paste steps. Simply right-click on the step and you'll see Copy and Paste options, and you can open up the duplicated step and make any changes you need. You can also enable and disable steps with a simple mouse click or shortcut key. This makes it easy to test specific parts of a sequence without the need to run the entire sequence. You can just toggle the steps you don't need off. This is also useful for troubleshooting sequences. Lastly, sequences now automatically update if a curve, value, or results name changes. For example, in this sequence, this step has an output from this analysis step, named fundamental. This output curve is used in many subsequent steps, like this one here. In earlier versions, if you change the step output name, you would need to update it in every single successive step that references it. Now, when you rename the step output data, that new name automatically propagates to all subsequent steps that use it. This makes it easier to edit sequences and ensures that workflows are not accidentally interrupted by renaming data in a step editor. SoundCheck now measures acoustic loudness according to the ISO 532-3 loudness standard. This can be used to measure both complex and sign-based recordings of music and noise, and enables calculation of the perceived short-term and long-term loudness in phones or sounds over time. Here I have a broadband time-varying sound. If you look at the level versus time graph, you can see the dBSPL level is time-varying, and the short-term loudness also varies with time. The long-term loudness, calculated according to ISO 532-3, is stable at around 77 phones. This functionality is added to optional module 2031, which now includes this new standard as well as Wicker loudness for spectral and overall loudness. In SoundCheck 23, we've integrated our offline statistics options within the sequence editor to offer more flexibility. This lets you calculate statistics across multiple devices, for example, multiple microphones in an array, as well as on repeated runs of the same device. Here I have a 6-microphone array. In earlier versions of SoundCheck, statistics would only run across each device, not all devices. Now when you open a statistics step, you have this offline statistics option, which lets me drag over my 6-microphone curves. Let's name this group Mic Array. I'll select the statistics I'm interested in. In the distribution, we have a few more options, like best and worst fit to average. Now, when I run my sequence, it will automatically average my microphone response across all 6 mics in the array. That's this mic array mean line on the graph here. And I also have all the other statistics that I selected here in the memory list. You can now autosave metadata in text and Excel formats in addition to TDMS, and you can also sort the frequency column of each curve going into the file. You configure this in the autosave step. Just select whether you want to save to Excel or text. If you are sweeping from high to low frequencies, you can check this box here to flip it and record your data from low to high. Let's save to Excel and tabulate the data in ascending order. Now I'm going to run my sequence. You'll hear it sweep from high to low. It's asking me to enter the metadata. Now let's take a look at the file it generates. You can see here I have the metadata saved, and also that it's logged in ascending order, even though we swept high to low. The MDT 4000 turntable can now be controlled via Ethernet in a sequence. This is useful when the turntable is not close to the SoundCheck computer, like in an anechoic chamber. You add a custom step in your sequence, enter the IP address for your turntable, or search for it on the network, and set the starting position. In this step here, we can set the turntable to move and make a measurement every n degrees. We'll configure it to move counterclockwise in 10-degree steps, and wait until rotation stops to play the test signal. When we're done measuring, we have another custom step that returns the turntable to its home position. Another neat thing about this is that here in the custom step, we have a live link to a software version of the front panel display, so anytime you want to check up on your turntable and see what it's doing, you can just open this window. You can also use this to access advanced controls, such as controlling the speed and acceleration of the turntable. This sequence I just used is included with SoundCheck. SoundCheck 23 includes full support for AudioConnect 8x8, Listen's newest multi-channel audio interface. This high-resolution interface has 8 analog input channels with microphone power, 8 analog output channels, and 2 digital SPDIF channels. You can connect 4 of these for up to 32 synchronized analog input and output channels. All configuration is via the software. Just plug in the USB cable, and the hardware table auto-populates. You can use headphones or loudspeakers to real-time monitor the input of any channel with the output on another channel. This is useful if you want to hear the sound that is being recorded by a microphone in another room or artificial ear. SoundCheck handles up to 64 channels simultaneously, so SoundCheck with AudioConnect 8x8 is a great solution for any high channel count audio measurement application. That's a quick rundown of the new functionality in SoundCheck 23. If you'd like to see more detailed demonstration or get a quote for an upgrade, please contact your local sales engineer or Listen rep. Thanks for watching.